Welcome everyone to another deep dive on the explainer. Today we are targeting a very specific and honestly highly misunderstood area of the Cambridge Mathematics 9709 syllabus, definite integrals. But listen, we aren't just going to sit here and crunch numbers or look at basic math equations. Instead, we are doing something much more powerful. We are essentially opening up the official examiner's playbook. We're going to discover exactly how these examiners evaluate your working out and where the invisible line is drawn between a totally average grade and those top-tier A-star marks. Think of this explainer like a master chef's recipe for success. You might have the raw ingredients, the basic math facts, but today we're going to learn the strategy of cooking up that analysis and exactly how to plate your final evaluation for the examiner. And hey, even if you're joining us from syllabus code 0580, 0606, 4024, 4037, or 4040, stick around because this strategic mindset is universally applicable. Look at this incredible insight we pulled straight from the senior examiner level. It says, most students lose easy marks on integration, definite integrals, but after this explainer, you won't be one of them. I really want you to let that sink in for a moment. Read between the lines here. They are absolutely not saying that students lose marks because the calculus is impossibly, mind-bendingly hard. No, they are explicitly stating that students are dropping incredibly accessible, easy marks due to completely avoidable errors. We're talking about errors in process, errors in presentation, and errors in basic analytical thinking. The sheer mechanics of integration, that's just your baseline. It's just the flour in the recipe. It is how you apply, structure, and present those mechanics that actually earns you the points on exam day. Our ultimate goal today is to ensure you capture every single one of those marks without breaking a sweat.
Which brings us to a really fascinating core question, a central mystery that honestly plagues examination boards year after consecutive year. Why do students find the distinction between key terminologies so hard? Why is it that a candidate can sit down, perfectly execute a massively complex algebraic manipulation, yet completely fail to distinguish between the specific command words required by the context of the question? Well, I'll tell you, it happens constantly. You've probably felt this yourself. Candidates walk into the exam hall, the adrenaline is pumping, they see an integral sign, and boom, they just start calculating blindly. They operate like mechanical calculators rather than strategic, analytical thinkers. But the syllabus strictly emphasizes that mastering definite integrals requires a connected conceptual understanding. The terminology in the prompt is literally a map telling you exactly which mathematical tools to use and when.
Okay, let's dive into this and look at the path we're taking today. First, we'll uncover the integration trap. Second, we'll build out the procedural framework. Third, we're mastering critical analysis. And finally, we will go through the top examiner warnings. Before we continue and get into the real meat of this strategy, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's begin with Section 1, the integration trap and the core concepts, because mastering this topic takes way more than just raw mechanical calculation.
The very first step to truly mastering definite integrals is realizing that this topic is absolutely not an isolated island of mathematics. The trap, the biggest pitfall, is believing that if you just memorize the standard integration rules, you are somehow safe. But the holy grail for Cambridge examiners is seeing students exhibit connected, conceptual understanding that is fully transferable to unfamiliar contexts. They are actively, purposely testing how well you can adapt your theoretical knowledge to a brand new scenario you have literally never seen before. Think about it. If you only know how to integrate a standard polynomial because you've memorized a textbook example, you are probably going to freeze up when the exam throws a curveball, like a multi-layered problem involving real-world physical contexts or intertwined trigonometric identities. You need to know the why. Why does the definite integral calculate what it does? So that when the context completely shifts on you, your mathematical foundation remains absolutely rock solid.
Now, what's really interesting about this slide is how we build that foundation. This connected understanding relies on what we call a core principles architecture. Let's break these down. First, precise definitions. You need to know exactly what your limits represent in physical or geometric space. Second, causal relationships. You have to understand how tweaking a single parameter completely alters the outcome of your integrals. Third, and guys, this one is massive, cross-topic connections. Principal examiner reports continually highlight that candidates who reference cross-topic connections achieve significantly higher marks. Definite integrals connect to kinematics, they connect to coordinate geometry, they even connect to complex numbers. Fourth is systematic analysis, and fifth is evidence-based reasoning, which simply means your mathematical working is the undeniable evidence that justifies your final answer. Mastering this exact architecture is what elevates you understanding from basic to brilliant.
Let's move on to Section 2, the procedural framework. This is exactly where your theory meets the paper to earn those all-important method marks.
A lot of students fall into the trap of thinking that math exams are purely binary. You either get the final answer right for full marks, or you get it wrong and score a big fat 0. But I'm here to tell you the examination system is highly nuanced. This brings us to the method mark strategy, which is essentially your ultimate safety net in the exam hall. Method marks are earned for demonstrating the correct procedural process and analytical framework, rather than just delivering the final answer. What does this mean for you? It means that if you set up the definite integral perfectly, apply the correct upper and lower limits, show the absolute correct integration technique, but then say you make a tiny, silly arithmetic error in the final calculation step, you will still walk away with the vast majority of the marks for that question. Your process is your proof. Examiners are desperately looking for a systematic sequence of identifying key elements and executing analysis with clear, logical working.
So, let's break that systematic sequence down into 5 highly actionable steps. I want you to use this exact flow on every single past paper question you practice from now on. Step 1. Deconstruct the question and extract relevant data. Please don't just start writing the second you see the prompt. Read the scenario, identify the limits, note the function, spot any intersecting lines. Take a breath. Step 2. Select the analytical framework. Are you finding a straightforward area, or is this a volume of revolution? Decide your approach before your pen hits the paper. Step 3. Execute with clear notation. Use proper integral signs, write out clear limits, and for the love of math, definitely do not drop your dx. Step 4. Verify results. Does the magnitude of your answer actually make logical sense in the context of the extracted data? If you're calculating the area of a tiny triangle and get a million, something's wrong. Step 5. Present correctly with the appropriate terminology. This exact deconstruct, solve, evaluate flow is what structures top-tier problem solving. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. And this brilliantly illustrates the final piece of the procedural puzzle: presentation conventions. Just like plating a meal, how you present your information in definite integrals follows strict rules. You need proper headings, correct terminology, appropriate formats, and clear annotation. For instance, if you are finding the complex area between 2 curves, you must clearly annotate which integral represents which curve before you subtract them. Don't make the examiner guess. If you are changing variables for a complex substitution, state it explicitly. Sloppy formatting, missing annotations, and a chaotic layout will cost you points, no matter how genius the underlying math is. You have to make it impossibly easy for the examiner to give you those method marks. Your exam paper should literally read like a clear, undeniably logical argument from start to finish. Right, let's jump into Section 3, Mastering Critical Analysis and Learning to Genuinely Think like an Examiner.
Problem solving at this advanced level requires you to evaluate the given information, break it down meticulously, and make justified mathematical recommendations. The top-scoring candidates don't just do math, they demonstrate evaluative thinking. What does that mean? First, you must question given assumptions. Are the boundaries of the definite integral explicitly given to you, or is there a hidden step where you need to calculate intersection points first? Second, you must consider different perspectives. Ask yourself, is it actually more efficient to integrate with respect to x or y for the specific volume problem? Third, you absolutely must justify decisions with evidence, meaning your step-by-step mathematical working logically and inevitably leads to your conclusion. And finally, you need to identify limitations and alternative interpretations. If a particular mathematical model breaks down at a certain boundary point, mathematically demonstrate exactly why it happens. Justifying every single decision like this is precisely what separates a pretty good script from a truly great A-star response.
Now, comparative analysis is another absolutely critical skill, especially when you are dealing with complex data interpretation questions. Very often, you'll be asked to analyze different mathematical models or entirely different approaches to a problem. The golden rule here is balance. You must identify the similarities, as shown on the left, but you also have to identify the differences, on the right. Top candidates don't just write a bulleted list of these. They use comparative connectives to link them together.
They support every single comparison with solid, undeniable mathematical evidence, and they draw conclusions about their relative importance. For example, imagine comparing the exact area found via definite integration with a rough approximation method. You evaluate the quality of the evidence, you explicitly note the limitations of the approximation, and you justify exactly why the exact integral provides a superior, rigorous result. It's all about building that analytical narrative.
Let's move to our final segment, Section 4, Top Examiner Warnings and what we call the Rule of Three.
The principal examiner reports are essentially a gold mine. They give us incredible, hard data on where candidates consistently fail year after year. By studying these reports obsessively, we've identified the 3 most dangerous traps that ruin perfectly good exam papers. Let's look at trap number 1, using the wrong approach for the specific context. This happens when a student blindly memorizes a formula, but applies it to a scenario where it structurally just doesn't fit, like furiously trying to calculate a volume when the command word clearly asked for a 2D area. Trap number 2, forgetting to check format and presentation. This is tragic. It's dropping the dx, it's forgetting the constant of integration on an initial indefinite step leading into your definite problem, or it's just presenting a chaotic mess that the examiner literally can't follow. And trap number 3, providing non-specific, generic answers. This classic mistake happens when a question requires a real-world contextual interpretation of the result, and the student just scribbles down a floating number without explaining what that number actually represents in the given scenario.
So the crucial point is captured right here, in this direct examiner alert. Always link every point back to the given scenario. This is a non-negotiable rule. When you finally finish your incredibly complex definite integral, and you arrive at a value, let's say it's 42.5, you cannot just stop and move on. You must look back at the original data provided. If the question was modeling water flow in a pipe, your answer isn't just 42.5. It's 42.5 liters. If it was modeling kinematics and distance, it's 42.5 meters. You must explicitly tie your mathematical evidence back to the real-world or theoretical context provided in the prompt. That final simple link is very often the single difference between getting the final accuracy mark and losing it entirely. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries. But that only happens if they practice consistently with our weekly videos. So here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by.
As we wrap up, I want you to look at your notes today and ask yourself a serious question. Will you fall into the classic trap of giving generic answers and making rushed, panicked calculations? Or will you take what we learned today and use this procedural methodology to build an undeniable, bulletproof case for every single method mark? The examiner's playbook is literally in your hands now. You know that precise definitions matter. You know that setting up an analytical framework before you calculate is essential. And you know that to truly master definite integrals, you must create a visual, logical story with your working out. Your next step? Go pull up a past paper and apply this directly. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Until next time, keep analyzing systematically and keep exploring.